Hello viewers. So today I'm having this problem from SS Krotov again. This problem is from the segment of electrodynamics. The question number is 3.3. Okay, so it is a very standard problem. Let me just formally once go through with the questions. I'll just read that question and then we'll see the solution of that problem. Okay, so the question says that determine the strength of electric field of uh, determine the strength of E, okay, of the electric field at the center of a hemisphere produced by a charge uniformly distributed with a density over the surface of a hemisphere. Okay, so if you see guys, basically this problem is what this problem says like this, that let's say if you have a, I'll just write solution. Okay, so solution. So guys, what is this question actually? This question says like this, that let's say if we have a, okay, let me make first, there is a circle like this. I'll just try to make a proper figure first and then we'll go on the discussion. So suppose guys, this is the picture we are having, and here I'll do a little bit construction for you. Okay, yeah, I think that would be best. Yes, so guys, if you see, this is a spherical shell. Okay, this is a hemispherical shell, and here let's say guys, the radius of this is r. Okay, the radius of this is what guys, r, and on the surface of this hemispherical shell, let's say the charge is what, charge is sigma, which is available. Okay, let's assume this sigma as a your charge density. Sigma is what guys, the charge density here, and the question says like this, that uh, calculate the electric field at the center due to this hemispherical charge shell. Okay, at the center of this hemispherical shell. Okay, so this is the problem, and to solve this problem guys, we need to have the basic understanding of what, how to take an element. Okay, and then of course the integration, and that's it. Okay, this problem is pretty much straightforward, and most of the teachers when they are teaching the electrostatics, they take this as an illustration in the classes. Okay, so there is no rocket science, I would say. It's a pretty simple straightforward problem. Let's try to understand these problems uh, from the basics. Okay, so if you see guys here, if I show you, this is a hemispherical shell. You know that if you want to make a shell guys, you want multiple rings. Okay, ring elements, you want a multiple ring elements like this. Okay, these ring elements, if you see guys, this ring elements, this ring elements, okay, this ring elements which I am making here, if you see these ring elements, when you combine, okay, you are going to get a shell. Okay, so to solve this problem, the simple idea is that take a ring element. Okay, and due to that ring element, calculate the field at the center of the shell, and if you can get some symmetry, the question might be get easier after that. Okay, so let's see. So if you see here guys, I'll take a ring first. Okay, I'm taking a ring here. Let's say this is a ring I am taking. Okay, and let's say guys, this is using the polar coordinate. I would say I will locate the position of this particular element. So let's say guys, this is the position of this ring element, from the origin, which is the center, we are locating this position. And because this is theta guys, so if I move a small angle in the direction, if I move small angle in this direction, this angle will be what guys, d theta. Okay, I hope this kind of a basic understanding you would be having. So guys, this angle will be what, d theta. Okay, this angle will be what, d theta. So now if you see guys, this ring element, we know that from the ring you know how to calculate the electric field guys. So you know that if you take a ring element and the electric field you want to calculate on its axis, okay, so the electric field that will come, which will be what, along this direction only, which is going to be what, along this direction only, which is along the axis, either inward or outward depending on the nature of the charge. So here because we are taking the positive charge, we know that the field due to this will be what, in this direction only. And similarly guys, for all the other elements also it is going to be what, in this direction only. So it means we don't need to do any kind of vector calculation, okay, where the things would get complicated. Just what we have to do, we have to calculate the electric field due to this ring element on this axis, okay, at this point, and then the same idea we have to use for the other elements, and then we have to integrate. Okay, so a very simple approach. I hope till this you are with me. So let's see guys here. What I'm going to do, I'm going to write the field equation due to this ring element. Okay, so guys, let's say the field, the DE, okay, I'll put here only DE, the electric field due to this ring element would be how much guys. If I write, it will be, you if you remember the formula guys, that is K dq divided by x square plus r square की power 3 by 2. Okay, k dq, k dq x square plus r square की power 3 by 2, and here guys there would be an x. Okay, there would be an x. So kqx upon x square plus r square की power 3 by 2, that would be the formula that you are going to have for the ring element. Okay, so if you see guys here, the x would be, the x would be this distance for this particular ring element, and this would be what guys, this would be the r for this element. Okay, I'll change the color once because I feel it is getting fused in the diagram. So guys, this is your x that is going to be, and this is going to be r for this particular element guys. So let's write the x and r and as well as dq in the terms of what guys, the theta and sigma, so that the variable that we are going to have will be only single variable, and then with the line integral we can solve the problem. Okay, so if you see here DE guys, okay, if I write DE, so DE will be simply K, okay, DQ will be how much guys, that will be sigma into the area of the ring element. So area of the ring element, if you see guys, that is simply what, that is sigma into, if you see guys, if I'll zoom this thing, okay, if I'll zoom this thing for you, then you can get that what would be the surface area. Okay, so for that I'm going to zoom in. So if you see guys here, if you see, this is the surface. Okay, this is the surface guys, and this length will be nothing but what, r d theta. Are you getting my point or not? And the radius, that is what, that is this radius that we are going to have, this radius. Okay, so this is the radius, and this is what guys, this is your the width of this ring element. Okay, so if you talk about the radius guys, this will be simply because this is how much, this is r, this is how much r, so this will be how much, because this angle is theta, so this will be how much, r sine theta, and this will be how much guys, this will be r cos theta, and this will be only your radius, r cos theta. I hope you're getting my point. So x will become how much, that will become this, which is what, r sine theta, and this will become how much guys, this will become r cos theta. I hope you're getting my point. So I'm going from very fundamental to explain everything guys. And the width of this ring element is going to be how much guys, that is going to be r d theta. Okay, r d theta, because that is the arc that is going to form here, so this will be what, r d theta. So now let's approach this problem, guys. Now, so if you see here, I can write k sigma, and then I can go like this way, that this will be how much, 2 pi small r into r d theta divided by x square plus r square e power 3 by 2 into that x is also there here, guys. Okay, so kqx divided by x square plus r square की power 3 by 2, that is going to be the field due to this element. Okay, now just I have replaced the dq value in the term of r and d theta. Now guys, let's remove this variables small r and the small x, because these are going to vary with the different ring element, guys. As you are going to take different ring elements, let's say if you take this element, so in this element, guys, there is a different r is going to be there and different x is going to be there. So if you see, these two both are going to be what, variable. So there are, right now if you see in this equation, there are three variables. Small r is a variable, x is also variable, and d theta, which is also a variable. So but I want to convert everything in a single variable, and that single variable that I am looking up to is what, the theta only. Okay, so guys, here if you see, because if I do the a little bit construction for you here, so if you see, this is this is this is how much, guys? This is going to be r sine theta, and this is going to be r cos theta. So from here we can say r sine theta is going to be equal to x, and r cos theta is equal to going to be what, r. Okay, so if I put both the values, guys, here in the equation, what I will get, I will get dE is equal to k sigma into, don't get confused, guys, this is not x. Okay, this is not x, this is just multiplication. So sigma 2 pi r is equal to r cos theta into r d theta into r sin theta divided by x is how much, guys, r sin theta. So r square sin square theta plus r square cos square theta key power 3 by 2. Okay, so if you see, guys, here the equation will become very easy for us. So it will become how much, guys, if you see, k sigma 2 pi r cube sin theta into cos theta into d theta divided by, here, guys, I can write r cube, and sin square theta plus cos square theta will be what, guys, 1. So it will become what, 1 only. You can see the simple math calculation that I am doing here. So r cube is going to be what, guys, cancel, and the dE, the final term that is going to look like is 2 pi k sigma and then sin theta into cos theta d theta. Okay, now, guys, here divide by 1 if you just want to write. Okay, now, guys, here I want to integrate this ring element. So if you see, guys, the ring elements will start from here, the small ones, and then the bigger ones, and then it will go up to like this. So to get the lowest element, guys, the theta should be how much, it should be 0. Okay, and the upper one, the smallest ring element, guys, the theta should be what, pi by 2, means the position, the angular position of the lowest ring element is going to be what, theta equal to 0, and for the smallest, the upper one, the theta is going to be what, pi by 2. It means theta is changing from 0 to pi by 2 to accommodate all the ring elements that is going to exist on this spherical shell. Okay, so what I can say, I can say, if I want to get a field E, if I want to get a field E, guys, that is what, integral dE, and that is equal to be what, guys, it is equal to be 0 to pi by 2 pi k sigma sin theta cos theta d theta. Okay, now if we solve this problem, the E will simply come how much, guys, if you see, So what I'm going to do, I'm going to take the 2 into the equation, and let me write like this: pi k sigma, okay, 0 to pi by 2. Guys, 2 here, 2, and the sine theta cos theta, if I club, it will become what? Sine 2 theta. So I'll club all of them. So sine 2 theta d theta. Okay, if I integrate now, guys, so E will become how much? It will become pi k sigma. Okay, here only I'll just write. Okay, so sine 2 theta integration will be what, guys? It will be pi k sigma by 2. Okay, and it will be minus cos 2 theta. Okay, and limit will go from 0 to pi by 2. Okay, so if I put the values here, so pi k sigma divided by 2, and if I put the upper limit, it will become minus. Also I'll take outside only, guys, okay, for now. So cos pi by 2, if you put instead of theta, so you will get cos pi, which is equal to what? Minus 1. And then, guys, if you put 0, that will be what? That will be also 1 only. So it will become minus 2 multiplied with the minus. It will become what, guys? It will become your how much? It will become minus, sir, guys, 2 will be cancelled. So if you see, it will simply come how much? It will come pi k sigma. Okay, that would be the answer if I put in a standard way. So guys, k we can replace with the what? 4 pi epsilon naught. Okay, so 4 pi epsilon naught if you put, so pi will be, guys, cancel, and it will become sigma upon 4 epsilon naught. Okay, and that would be what, guys, your answer for this particular problem. And you can remember this also as a standard case, because many times this answer might be helpful in certain problems. Okay, so I hope you understood, guys, this problem. I have discussed this problem from very fundamental, and I have discussed all the ideas, that what sort of ideas are going to be used in this particular problem. It is not a very difficult problem, I would say, but of course the understandings of basic fundamentals are required to solve this particular problem. Okay, so that's it, guys. I'll see you in the next problem. Okay.